Hi guys, I welcome you all to my channel CSNet Lectures. So in this session, we are going to have a continuation of discussion regarding types of graphs. So here we are going to discuss about two types of graphs, that is Euler graph and then Hamiltonian graph. Okay, so after discussing these two graphs, we are going to discuss another important graph, which is planar graph, and we are going to discuss one of the very important formula of graph theory. So it is handshaking theorem, which I have already told in the first session of graph types. I think so you will be remembering it, right? So now we will go for the discussion. So friends, we are going to start with the discussion of Euler graph. See friends, this is a very important graph type which you have maximum chances of getting questions in university examination or in any type of government examination, that is MCQ type questions you are having chances to get. Okay, so now we will go for the discussion. So what is a Euler graph? So Euler graph is nothing but it is going to have vertices and edges, as we have discussed already in many videos. What is a specific thing in Euler graph? So a specific thing which we are going to use it for identifying that whether it is a Euler graph or not is by means of counting the total number of edges. Okay. Then another thing is that if we have the edges. Okay. So by using the edges, we are going to start to visit the vertex at A. Okay, so this is the starting vertex and we are going to traverse all the edges. Okay, we are going to traverse all the edges and all the vertices and we are going to visit from A and all the edges and all the vertices without making any repetition, and we are going to terminate in the place where we have started. So if you do so, it is called as a Euler graph. Okay, so what is a Euler graph? We are going to start from one vertex and we are going to traverse all the edges without leaving any edges and without repeating any edges, and we are going to visit all the vertices and we are going to terminate in the place where we have started. So if you do so, it is called as a Euler graph. So friends, please make a note of it that Euler graph is used to visit or use all the edges without leaving anything. Okay, so that is called as a Euler graph. Then another thing for determination of Euler graph is if it is even. Please make a note, Euler means even. That is a shortcut, remember. So Euler means even. So what is this even word here? So each and every vertex is having even number of edges, then it is called as a Euler graph. Okay, so this is another one important keyword for identifying the Euler graph. Instead of traversing each and every edges and finding it, we can easily remember that the total number of degrees, that is the total number of edges that is attached to each and every vertex is even, then it is a Euler graph. So now can we determine here? See. For this vertex, we have 2 degrees. So friends, in the last class also I discussed what is a degree, what are all its types and so on. If you don't know the meaning, please visit all of my previous videos so you will be having a clear idea, right? So now, for each and every vertex you find. So the total number of degree is 2. So here also the total number of degree is 2. So here also the degree is 2, or here also the degree is 2. So the meaning is each and every vertex is having even number of degrees, even number of count of the edges, then it is called as a Euler graph. Right friends, are you clear what is a Euler graph? Right. So now we will go for Hamiltonian graph. So what is a Hamiltonian graph? See, both are having a same similarity, but there is a little bit of difference. So what is that? We are not going to consider the edges in Hamiltonian graph. So it is not necessary that we are going to visit all the edges. But here the condition is we are going to visit all the vertices by not considering the traversing each and every edges of a graph. So okay, can you understand? But here if you see, we are visiting all the edges and all the vertices without any repetition. But here we are visiting all the vertices without giving importance that all the edges are visited or not, right? So now, can you understand the meaning? So here we are going to start from a starting vertex, and we are taking care that all the vertices are visited by using any of the edges which is having more prevalence, right? So based on that we are visiting. So for example, you take from A I am starting. So I am visiting like this, A to B, then B to C, C to D and D to A. Now if you just watch keenly, I have not visited these two edges. Okay, so this is the difference between Euler graph and Hamiltonian graph. Okay, so in your Hamiltonian graph, you are not giving importance that all the edges has to be visited, but all the vertices has to be visited. But here we are going to visit all the vertices by visiting or traversing all the edges that is being present in the graph. Okay, so that is the difference between these two. And the important thing is, in Euler graph, if it is to be a Euler graph, the number of edges attached to each and every vertex is to be even. Friends, are you all clear? Right. So now we will go for the discussion of the next graph. So friends, now we are going to discuss about planar graph. That is another type of a graph. So the another name of planar graph is isomorphic graph. Okay. So another name of planar graph is, we call it as an isomorphic graph. Okay friends. So now you see this is a graph that is being given. So in this graph, so there are certain number of vertices. So these vertices are having edges that is being moving from one place to the another, that is one vertex to the another. So if you watch, the edges are having some intersection, that is they are crossing in order to travel from one vertex to another. So this is being crossing and this is also being crossing. Okay, so like this, the edges should not have intersection when it is traveling from one vertex to another. So I must have to change this ordinary graph into a planar graph. So how can I do this? I can change like this. See, like this. So you just take into consideration how many number of vertices are there. So 1, 2, 3, 4, 5, 6, 7 and 8. So there are 8 vertices. So can we draw like this? So we can draw like this. That is how we are going to change it into a planar graph or isomorphic graph is, we are not going to change the position of the vertices. Instead we are going to draw the edges without changing the position so that they don't cross within each other. So that I am going to make it. So for example, let me draw like this. V9. See, I am now changing the position. V3. Then V8, then V5. So what are the remaining vertices that are present? So above V8 is V1, isn't it? Shall we draw like this? Yes, we can draw like this. So next is V2. So like this we can draw. Then above V8 is V7. V7 and above V5 is V4. So I can connect like this. So I can draw like this, isn't it? So like this, I am changing the position of a normal graph which is having intersection of edges into a planar graph. Okay, so suppose if you do this, it is called as a planar graph. Friends, I think you are all clear about different types of important graphs I have discussed so far. Okay. So friends, now we are going to discuss a very important concept of graph theory. So it is handshaking theorem. So it is one of the very important concept, friends. So you may have maximum chances or possibility for getting questions in any way. Okay, so it carries a formula. So by using this formula, they may ask even problematic questions or theoretical questions or whatever it is. So you must have to remember this formula. So this is a graph. So this graph consists of 4 vertices and 4 edges. Okay, so it consists of 4 vertices and 4 edges. So here in this graph, I am going to implement this formula. So what is this formula? So a graph is satisfying this theorem if and only if total number of degrees of each vertex is equal to twice the number of edge. If we are going to calculate the degree of each and every vertex. Okay, so after finding the degree of each and every vertex, it will be equivalent to twice the total number of edges, right? So shall we proceed for solving this problem? Right. So now calculate the degree of each and every vertex, right? So what is the degree of V1? What is the degree of V1? So it is 2. Now degree of V2. So what is degree of V2? So it is also 2. Similarly for V3 also 2 and V4 is also 2. Right. So now you find the sum. The sum of all the degrees of each and every vertex is, when you add this, you will get 2 plus 2 plus 2 plus 2. So it is 8. Isn't it? So it is equivalent to 8. Okay, so when I find the degree of each and every vertex is 2, when I find the summation, it is equal to 8. So now, can you find the total number of edges for this graph? So the total number of edges for this graph is 4, isn't it? So 1, 2, 3 and 4. Okay, so when I multiply this with 2, I am getting it as 8. So now you find both are equal. Okay, so this graph is satisfying this theorem. So they may ask this type of problematic questions, that is, they may ask you some of the values by giving some other values. So you must have the ability to solve this problem. Okay, so please by heart this formula. So I request you to watch all those videos and even this, so that you will be having a clear knowledge of what are the different types of graphs that we are implementing in data structures. Okay friends, so we will meet in the next video with a different topic. Bye and thank you.